So number 5, what are some ways that energy can be transferred into or out of a system? And the first one you can actually see in A, B, and C. So if you look back at A, what did we do to get from A to B, to get from position A to up here? What happened?
We moved it up. What?
Yeah, we moved it up. What did I have to do to move it up?
Apply a force.
I had to apply a force. So what are the forces occurring while I'm lifting it?
Normal force.
Normal force and?
Gravity.
And force of gravity. So as I'm lifting it from A to B, here's my beanbag, we have a normal force and we have a force of gravity. When you're working with these forces in energy, you need to think about which ones are internal and which ones are external. So look at the system. What is in the system? It says the beanbag is in the system and the floor and earth are in the system. Is the force of gravity between objects that are both in the system, making that an internal force? Yes, because that's between the earth and the beanbag. So both of those are in the system. So this is an internal force. And what about the normal force? That's a force between what two objects?
Hand in the beanbag.
The hand and the beanbag. So this, is my hand part of the system?
No.
No. This is an external force. Okay, so it's an external force upward. Now, if I just have an external force upward, like right now, I'm exerting a normal force upward. Am I changing the energy of the beanbag? Am I causing it to change, get higher? No. So just having an external force is not enough. What has to happen?
It has to be greater than the internal force? Or
No.
greater than the other?
It
Has to be unbalanced?
Well, yeah, because once I unbalance it, what will happen?
It'll start moving
Where?
whatever direction the unbalance is going.
So if I want to increase the gravitational potential energy, where does the beanbag need to go?
Down.
If I want to increase it.
Oh, up.
Okay. So the force moves through some displacement. Okay, it started here, it ended here. So the normal force acted over this distance. So the displacement, there's the direction of the force. Here's the displacement. Okay, so you have an external force that acts through a displacement. And that changed the energy of the system. That it caused a transfer of energy into the system of the beanbag and the earth. And go ahead and draw that. Draw that in your diagram for A. We'll draw these for each one for A, B, and C. So draw the normal force, draw the force of gravity.
Should we draw it on the position B?
I would draw it between A and B.
Okay.
Hang in there. It gets a little tedious, all these details, but you'll get it all pulled together at the end. Okay, situation B. I pushed on the car to cause it to change speed here. So what was the direction of my force on the car?
Right?
It was to the right. That was the force of me. We also have a normal force between the cart and the table, and we have a force of gravity. Are any of those, well, let's see, is Fn, is that internal or external?
External.
Let's
The
see.
truck is our system.
The
It's
floor
between the
is on the
cart and the
system.
floor.
Oh,
and-
system is, okay.
It's
System
internal.
is forward. So it's internal.
It's internal, yeah. What about force of gravity? That's between the cart and the earth.
That is
Internal.
internal.
That's internal. Force of me pushing on the cart.
External.
That's external. So that is going to transfer energy in as long as it moves through a displacement. And it did, right? I pushed it for some distance. So this was the displacement and this was the external force. So this I'm going to label this as an external force here. Fn is internal and Fg is internal. Okay, so once again, we have an external force that acts through some displacement, causing an increase in the energy of the system, transferring energy into the system. It's doing this right here, creating a change in energy of the system. And the third one we had the bow just sitting here like this. And what did I do? I pushed left. Okay, so forces on the system during that time. We have the force to the left on the arrow. We will have a force normal and a force of gravity. Is the normal force internal or external to the system?
Internal.
Internal because?
Yeah.
Because it's between the bow, arrow, and floor.
The normal force.
That and the floor.
I was thinking, which one did I ask about? Yeah, so the normal force between the whole thing, right? It's between objects that are both in the system. Force of gravity, the earth
Well,
and
are
all
we
this.
considering the horse like part of the...
Yeah.
Okay.
Yeah, I know in the picture it's a person, so the horse is part of the system too. Where's the person? Oh, there he is. We lost the rider. Put this thing back together here. So the force is to the left, and then do you see that it had to be pushed through a displacement of about a centimeter?
That bow looks too big for him.
Okay, so the force is
A
this
little
way,
bit.
and the displacement was that way. What do you notice about the force and displacement for each of these?
They're in the same direction as...
Yeah, do you see that the force and the displacement are in the same direction? Okay, so those three are all examples of the first way of transferring energy into or out of a system. Part A, on 5, number 5A. The first way is when an external force, I'm not going to write this, so you'll just have to listen and write it down. An external force acts through a displacement.
So should that be on the
For A. I'll put it right. And no, the line isn't long enough for all of that. But part A.
So
Reason, yeah.
So an external force acts outside the system.
Uh-huh. When an external force acts through a displacement. And we're going to take a little bit of a closer look at this. So I have a little chart here. I'm going to take a little closer look at this idea of external force acting through a displacement. I have 3 events listed. The first event is the beanbag is lifted, like this. The second one, the beanbag is lowered. The third one, the beanbag is carried across the room
At constant speed.
at a constant speed, at a constant height. Also, okay? So for the first one, beanbag is lifted. Is there an external force on the system?
Of course.
Mm-hmm.
What direction is it?
Oh,
Up. So put a little up arrow in that box. It's the hand on the beanbag. And what's the direction of the displacement?
Up.
Up. So put a little arrow in that box. So put an up arrow here for that's the force of the hand upward, and then the displacement is up. Is there a change in the total energy of the system?
Yes.
Yes, it increased. Okay, so
it would
yes.
be like another up.
Just put yes. I would put yes. And note that it increased. Write that down. That's important. Okay, so when the force vector and the displacement vector are in the same direction, you will have an increase, a transfer of energy into the system. Okay, it has now more energy than it had before. Right? If you have a brick, right, it would have more energy if I had it up at the roof than if I had it right here. So the higher you go. Okay, the second one, beanbag is lowered. So here it is. I'm lowering the beanbag. Is there an external force on the beanbag during the lowering?
Yes.
What is it?
Okay.
Force of my hand. What's the direction of that force?
The same as gravity.
Upward.
It's
Am I
upward.
pushing
It's
down
just
on
less
it?
than gravity.
And just to make it easier to think about, just imagine I'm lowering it with a constant velocity.
Oh, so it's kind of going up.
Oh. Wait,
But not
that's
as strong as
balanced
gravity.
then.
This is like the elevator. If you have an elevator going
Yeah.
down at constant velocity, how does the tension in the cable compare to the force of gravity?
It's less.
plus
If the elevator is going down at constant velocity,
is the same. They're balanced.
you have to have balanced forces, yeah?
Yeah.
Seems like they would be different, doesn't it? Right? It's our intuition getting in there. But really think about it. And if I can convince you in the moment. So if you remember back, if we had this pattern we found, right, that if something has constant velocity, the forces have to be balanced.
Mhm.
So if I lower this at constant velocity, there are two forces on it. Force of my hand supporting it upward and force of gravity pulling downward on it. If I do this at constant velocity, how do those forces compare?
They're equal.
They're equal to each other. Even though that might feel counterintuitive. So,
So how come it wasn't equal when you were lifting?
they're equal. As long as I do it at constant velocity.
But we said there was an external. Oh wait, right.
Good question though. Yeah,
Okay,
it's a force from outside the system,
they're still balanced though.
but the forces themselves are actually balanced.
Okay.
We have an external force balancing an internal force. Yeah. Okay, so if I lower it, we have an upward force, so put an up arrow in that box for the external force on the system. It's my hand, and that's up. But the displacement is
Damn.
down, so make a down arrow. What happened to the total energy of the system?
No.
It decreased.
Does this
Did it
have
know?
the same amount of energy as this?
No, because it's lower.
It's lower, so
Well,
we can see
technically
that
gravity is stronger if you go lower.
the
isn't it?
energy decreased. If you're talking about, tall mountains to the surface of the
Yeah.
earth, yes, but for here to here, you can assume it's a constant. But you're
So
right.
no.
The farther you get away from the earth, the gravitational field strength is
Unless you go to the
decreasing.
middle.
Should go through the middle. Okay, so if you have situations like this where the external force is opposite the displacement, then you will have a decrease. You'll have energy actually leaving the system.